Welcome to another episode of C Sharp tutorial for beginners. This is part 6 of C Sharp tutorial. In this course, C Sharp.NET programming basics are covered. This is part 2 of LINQ in C Sharp. In the previous video, LINQ query syntax and query expressions were explained. Please watch that video before watching this video to understand essential concepts. In this video, query operators are explained, which are used to write queries using method syntax. Most of the LINQ operators take sequences as input and return a sequence or scalar value. But there are some operators which do not take any sequence as input, they generate their own sequences. Operators are implemented as extension methods, which makes it possible to chain the operators together using the dot operator. It simply means result of the first method becomes input of the second method and result of the second method becomes input to the third method and so on. Extension methods make this kind of code much easier to read and understand. And now another important point is that these methods are implemented as iterators. In other languages like Python, these are called generators. They actually create an enumerable class and an enumerator class at compile time. To refresh the concepts, you can watch the video on enumerators and iterators which I have already uploaded. Here is how the where operator is implemented. The first parameter of an extension method is always the name of the type on which it is applied, and this keyword is used before the parameter. And the second parameter is predicate function, which is a delegate, so you can provide a delegate or lambda expression. Lambda expressions are used extensively with LINQ operators. Please note the yield return statement in the method body. It tells the compiler that this is an iterator method, so create an enumerable class and an enumerator class at compile time. You can easily create your own query operators like this to implement some custom or domain-specific query logic. Here is a list of operators divided into different families. We will get through most of these operators one by one so that you can get feel of these operators. The where is the first operator in filtering category. It takes a sequence as input and filters the elements based on the predicate provided to it. In this example, where operator is applied on an array of integers named list1. The where operator filters the array and produces a new array with numbers which are greater than 50. The of type operator is another filtering operator. It takes a sequence as input and extracts elements of a specific type from it. Here in this example, list1 is an array of objects. It contains items of various data types. The of type operator is used to extract only integers from this array. And these are assigned to list2, which is an integer array. Projection operator. The select operator is used to perform a projection over a sequence. A selector function or delegate is passed as parameter. It applies the selector function to each item or element in the source sequence and produces an element in the result sequence. So if there are 10 items in the source sequence, there will be 10 items produced in the result sequence. Here in this example, the select operator is used to calculate square root of each element in the source array. So it just transforms the input to output by applying the square root function. Here is another example. The select operator is used to produce an object which contains less properties than the source object. And most often, this results to an anonymous type object. Here, only employee name and city are included in the output object. Please note, you can also access the index of the item in the source array. Here in this example, index is also passed as parameter to the lambda expression, and then it is included in the result object. The variant of the select operator that provides the index has no equivalent query expression syntax. The compiler automatically determines which version of the select operator we want. Also note that select operator must appear before the order by operator. This is important to get the indexes before sorting, not after. Select many operator. The select many operator transforms the source item to a sequence in the result. If you compare the declaration of select many, the select many returns a sequence, whereas the select operator returns a single item. This means that the output sequence may contain more or fewer items than the input sequence. Here, it is explained with an example. The select many operator accepts a lambda expression and two-char array method is invoked on each item. This produces a sequence of characters against each item in the names array. Here is another example where select many is used. This example assumes that a sequence of books exists and each book object contains a sequence of author objects. The lambda expression in the select many operator returns a sequence of authors to the result sequence. If you were writing a query expression, you could have written two from clauses, one from clause for the books sequence and the other for authors sequence. Select many also provides an overload to pass index of the array as we have seen with the select operator. Distinct operator is a set operator. It operates on a source sequence and produces a result sequence by removing duplicate items. Please note that the distinct operator relies on IEquatable.equals method to compare the objects. If it is not implemented, then object.equals method is used by default, and this may not produce the desired results. So see the department class here, it does not implement IEquatable interface. In the main method, I have created duplicate departments and added to the list. Even though I have applied the distinct operator on it, it still returns the duplicate departments. It is because the distinct operator ends up comparing the object references, and both of these objects have different object references. So I need to implement IEquatable interface so that distinct operator can work correctly, and here it is implemented, and now the distinct operator works perfectly fine. Aggregate operators. The aggregate operators operate on an input sequence and return a single scalar value. The returned value is not one of the elements from the input sequence, but rather some derived value computed from the elements in the input sequence. These operators are count, long count, sum, min, max, average, and aggregate. Count and long count operators both count the number of elements in the input sequence. The only difference is that count returns an integer value, whereas long count returns a long value. When there are large number of elements in the input sequence, long count operator is used. When there are small number of elements in the input sequence, count operator is used. Here in this example, count operator is used to count total elements in the numbers array. You can also pass a predicate to the count method. In this case, the count operator only counts the elements which meets the condition. Here in this example, I have passed a predicate to count only even numbers in the array. The sum query operator adds all the numbers together from the input sequence. Here in this case, the sum operator is applied on a numbers array, and it calculates the sum. You can also pass a delegate to the sum operator. This is required when the input sequence is non-numeric. Here in this example, the input sequence is an array of balance objects, and lambda expression is used to specify the amount property on which sum is calculated. Average operator is used to calculate average, and min operator is used to find the minimum number, and max is used to find the maximum number. They work similar to the sum method. You can use them without the delegate when the input sequence is numeric, and you must use a delegate if the input sequence is non-numeric. There is also an aggregate operator, which can be used to implement custom aggregate logic. For example, here I have used the aggregate method to calculate the sum of numbers array. You can also specify a seed value to the aggregate operator. Here I have specified 100 as a seed value and it adds up to the result. Order by operator. In a query expression, we use order by class for sorting. We can specify more than one fields or properties separated by commas. Additionally, we can specify descending keyword after the field name to sort the field in descending order. But in the method syntax, order by method is used, which accepts a func delegate. It means you can specify only one field with it. The order by class sorts the elements in ascending order. To sort in descending order, order by descending method is used. So you can use order by or order by descending depending upon the sorting order of the field. But if there are more than one fields to be included in the sort order, you must use then by or then by descending method to specify more fields. The order by or the order by descending works only with the first field in the sort order. Here in this example, order by clause is used in the query expression, and then the same is written using the method syntax. The first field, publisher, is written in the order by method, but for the second field, then by descending method is used, and for the third field, then by method is used. The reverse ordering operator simply reverses the order of the elements in the source sequence. So this is another operator which can be useful in some situations. It can also take the starting index and the number of elements to be reversed as parameter. Group by operator. The group by operator is used to group the elements of an input sequence, and it returns a sequence of sequences or groups. The group by operator takes a lambda expression to specify the key for which the groups are created. Each key becomes the parent node and all related objects are grouped as sequence under the key. Here in this example, group by clause is used on books sequence and the publisher field is mentioned as key in the lambda expression. The outer for each loop iterates through the groups sequence and the inner for each loop iterates through the inner sequence in each group. Our next topic is joining query operators. There are two joining query operators. These are join and group join. The joining query operators take two input sequences, combine them in some way, and output a single sequence. The first sequence is called outer sequence, whereas the second sequence is called inner sequence. There are two operators for joins. The first is join operator and the second is group join operator. The join operator acts like an inner join. It means only related objects appear in the result sequence. The result sequence is flat or non-hierarchical. Here is an example of join operator. It is applied on employees list. So employees is the outer sequence. The first parameter is the inner sequence, which is departments list in this case. The next parameter is a lambda expression which specifies key of the outer sequence. Similarly, the next parameter is also a lambda expression which also specifies the key of inner sequence, which is department ID in this case. The last parameter is also a lambda expression. It shapes the result. The group join creates an hierarchical result sequence. It picks all the objects from the outer sequence and make them root nodes. And it picks only related objects from the inner sequence and makes them child nodes. In simple words, it just arranges the related objects of the inner sequence to the objects of outer sequence. Here is an example of group join. This example makes all departments the root nodes and then assigns the sequence of employees to each department. All the parameters of group join are similar to join operator except the last one. The lambda expression accepts a department element and an employee sequence that is used to produce output sequence. Please note the EPS sequence is directly assigned to the new anonymous object. This forms a hierarchy. Note that two loops are used to iterate through the result sequence. The first for each loop iterates through the departments, whereas the inner loop iterates through the employee sequence inside each department. If you examine the output, both of the departments appear in the output, and only related employee elements appear under Department 10, which is Sales Department. No employee appears under Department 20, which is Accounts Department. Element operators. The element operators take an input sequence and result a single element or some other default single value from the input sequence. In this way, the element operators do not return sequences. Here is a list of element operators which return only single element from an input sequence. The first operator returns the first element, the last operator returns the last element in the sequence, and the element at operator returns an element at a specified position in the sequence. The single operator assumes that there is only one element in the sequence and it returns it. The important point to note is that these operators raise invalid operation exception when there is no specified item found in the input sequence. In case of a single operator, this exception is also raised when there are more than one elements in the input sequence. However, there is another set of element operators which return a default value instead of raising an exception when no specified element is found. For reference types, the default value is null. For numeric types, it is 0. For Boolean type, it is false. These operators are first or default, last or default, element at or default, and single or default. These operators also has overloads which take a predicate as parameter. However, the element at and the element at or default are exception. These two operators do not allow to pass a predicate as parameter. Here is an example which shows how the element operators are used. Please note the try-catch blocks which are used to catch the invalid operation exception because these operators do not return the default values. Here, predicates are passed to these operators. Please note the element at do not accept any predicate. Here in this example, first or default operator is used. So this will return a default value. The department in this case is a reference type, so null value will be returned if the element is not found. So it is checked for null in the if block. You can do the same for other element operators which return default values. Here is an example of single or default operator. This operator can throw an exception if there are more than one elements in the input sequence. So it is enclosed in try-catch block. And if there are no elements, it will return a default value which is null. So the result is checked for null value using an if statement. In simple words, when you are using single or default, you must check for null and also for an exception. There is another operator known as default if empty. It returns the default value when there are no elements in the input sequence. Here, the default if empty operator is applied on list, and it returns null as default value because the source list is empty. You can also specify the default value as parameter. For example, here I have specified none. So, none is returned as default value when the list is empty. Here in this example, none will be printed. Now let us see partitioning operators. These operators return only a subset of elements from the input sequence, and these are useful in implementing paging logic. These operators are take while, skip, and skip while. Here, take operator is applied on employees collection and 20 is passed as parameter. So it will take the top 20 elements from the input sequence. The take while operator is used and a predicate is passed to it. It will return elements till the predicate returns a true value. It will stop when the predicate returns a false value. The skip operator skips n number of items and includes rest of the items in the output. Here in this example, it skips first 20 items and takes the rest. Here is an example of skip while operator. It skips the elements till the predicate is true and includes all other items to the output. The set operators takes two sequences and produce a single sequence as result. We have already covered the distinct operator. The concat operator just takes all the elements from both the sequences and produces a third sequence. So the total number of elements in the result is equal to the total number of elements in the first sequence plus total number of elements in the second sequence. If you notice, David is appearing twice in the output. If you do not want duplicates in the output, you can use union operator. The union set operator concats the sequences, but it removes the duplicate elements. Here I have used the union operator and now David is appearing only once in the output. The difference between union and distinct is that the union takes two sequences as input and returns a distinct element, whereas distinct operator takes only one sequence as input and returns distinct elements. The intersect operator only takes common elements from both the input sequences. Here in this example, only David is displayed because it is the common element in both of the input sequences. The accept operator returns all the elements from the first sequence which are not found in the second sequence. So, here in this example, only Robert and James are two elements in the first sequence which do not exist in the second sequence. There are also some operators known as quantifier operators. These take one or more sequences as input and return true or false. For example, the contains operator takes a value as parameter, searches the input sequence for the value, and if the value is found, it returns true, otherwise false is returned. The any operator returns true if the input sequence has at least one element. It is a way to check whether the input sequence is empty or not. You can also pass a predicate as a parameter. In this case, the any operator returns true if an element exists which meets the predicate condition. The all operator accepts a predicate and applies the predicate against each element in the input sequence. It returns true if all the elements satisfy the predicate condition. The sequence equal operator compares two sequences and returns true only if they both have exactly the same elements in the same order. Here in this example, sequence 1 and sequence 2 are both equal because they both contain the same elements in the same order. So the sequence equal returns true in this case. Okay, this topic ends here. The purpose of this video was to introduce you to the LINQ query operators in C#. A lot of operators are covered in this video. You can start writing LINQ queries using the method syntax, and you can write your own query operators if you want to. Please ask questions in the comments section and let me know your feedback. Please subscribe to my channel for upcoming videos on C# and also like and share this video with your friends. Thank you for watching.